Good day, everyone. My name is Regina S. Omnos, and I am going to present my mathematical investigation entitled Math Behind Sudoku using magic square of order 3 to solve Sudoku grid problem. So, when one hears that no math is required to solve Sudoku, what is really meant is that no arithmetic is required. So, the puzzle does not depend on the fact that the 9 placeholders used are the digits from 1 to 9. So, any 9 symbols would serve just as well to create and solve the puzzle. So, in fact, mathematical thinking in the form of logical deduction is very useful in solving Sudokus. Now, for my introduction, Sudoku is a puzzle that has enjoyed worldwide popularity since 2005. To solve a Sudoku puzzle, one needs to use a combination of logic and trial and error. So Sudoku, originally named Number Place, was created by Howard Garnes in the US in 1979 and first published later that year in Dell Pencil and Puzzle Games. So at first, interest in Sudoku was minimal until it reappeared in print and was given its current name by the Japanese publisher Nikolai in 1984. So the game grew in popularity in Japan and was renamed by the publisher Nikolai to Sujiwa Dokoshi ni Kageru, which translates as the digits must remain single. So this was eventually shortened to Sudoku or single number. Now, Sudoku grid, so based on the figure shown in the right side, Sudoku grid consists of 81 squares divided into 9 columns. As you can see, 9 columns marked A through I and 9 rows marked 1 through 9. So the grid is also divided into 9 3 by 3 subgrids named boxes, which are marked box 1 through box 9. So Sudoku most commonly appears in its 9 by 9 matrix form. So the rules are simply to fill in the matrix so that every row, column, and a 3 by 3 submatrix contains the digits 1 through 9 exactly 1. So dapat isa ra jud siya 1 to 9 nga numbers. Dili siya pwede magbalik-balik sa kanang row, sa column, and then sa 3 by 3 submatrix. So each puzzle appears with a certain number of givens, and the number and location of these determine the game's level of difficulty. Now, here is the statement of the problem of my study. So, taking Sudoku one step further, this study will talk about using magic square of order 3 to solve Sudoku grid problem and the algorithm or the proposed algorithm used in making them. So, this study seeks to answer the following questions. Number 1, how is the proposed method used in solving the Sudoku grid problem using the magic square of order 3? Number 2, is the proposed algorithm able to solve the Sudoku problem efficiently? Alright, now, Sudoku problem. So, Sudoku, before we proceed to the magic square, let us discuss first about Sudoku. So, Sudoku is a popular logic-based combinatorial optimization problem. So, the puzzle starts with a certain locations filled it, which can be a great number or very few depending on the puzzle complexity. A Sudoku puzzle consists of 81 cells contained in a 9 by 9 grid. Each cell contains a single integer ranging between 1 and 9. The grid is further split up into 9 3 by 3 subgrids. So the purpose of Sudoku is to fill up the entire 9 by 9 grid such that the following constraints are met. So number 1, each row of cells is only allowed to contain the integers 1 through to 9 exactly once. So each row. So dapat ang each row sa atuang cells is ang atong 1, 2, 3, 4, 5, 6, 7, 8, 9 each number ana niya dili jud magbalik. Well, dili pwede nga na ay ni balik si 2, ni balik si 3, or ni balik ba si 6. So dili na siya pwede. And then number 2, each column of cells is only allowed to contain the integers 1 through to 9 exactly once. And then number 3, each 3 by 3 subgrid is also only allowed to contain the integers 1 through to 9 exactly once. So as you can see here, in figure in the right side, ang example, so kaning below, dili sa kaning sa taas, kaning sa lalom, is atuang each row, each column, o atuang each 3 by 3 subgrid, is wala dyoy nag-repeat nga number. Alright, now let's proceed to the magic squares. Now, magic square is a square matrix n by n with integer elements between 1 and n squared, and where the sums of the elements of all lines, columns, and the two main diagonals are equal to the magic sum or magic constant, which is given by the rule C sub n, this is C sub n, is equal to n times n squared plus 1 over 2. Now, the symbol C sub n denoted the magic sum or magic constant. Also, an order n magic square is an n by n matrix containing the numbers 1 to n squared, where each row, column, and main diagonal are equal to the same sum. So, the figure in the next slide shows a sample magic square with n is equal to 3, where the magic sum C sub 3 is 15. So this line sum invariance depends on only on the order n of the magic square. So magic square of order 3, as you can see here, atong magic sum is 15. So kung atong isum si 2, 7, 6, 15, exactly 15. 9 plus 5 plus 1, exactly 15. 4 plus 3 plus 8, exactly 15. So each row na siya. Kung each column ta, i-plus na to si 2, 9, 4, exactly 15. 7 plus 5 plus 3, exactly 15. 6 plus 1 plus 8, exactly 15. And then, kung i-diagonal nato siya, exactly 15 yapon siya. Kay 2 plus 5 plus 8, exactly 15. So, muna siya rule of a magic square of order 3. Now, here is other examples of magic square of odd order 3. So, exactly 15 jud siya, no? 4, 9, 2, so 15. Okay. Now, let's proceed to the algorithm. So, this algorithm is called heuristic algorithm. So, the term heuristic stands for thumb rules. So, the rules which work successfully in many cases, but its success is not guaranteed. Heuristic algorithms, or simply heuristics, have to be used in order to find near optical or logically optical solutions. Heuristic algorithms seek for high-quality solutions at a reasonable computational time, but cannot guarantee that a problem will be solved in terms of obtaining the exact solution. It may not be, or it may not even be possible to state how close to optimality a particular heuristic solution is. So, here is the proposed algorithm of my study. So the research proposed, or the study proposed 10 steps to solve Sudoku Grid Problem. A 9 by 9 by using magic square of odd order as 3 as follows. So this is from step 1 to step 10. So, kung ako ni siyang basahon without figure is confusing kayo siya. So, I made a figure, not in each step, but kaning in every, in akong gi-combine ang each region. So, na ay, like for example, ang first region, second region, and third region is giusa nako siya. And then 4th region, 5th region, 6th region, giusa po nako siya og figure. So let's go to the figure here. So in this research, all cells in Sudoku Grid are empty, and this empty increase the game's level of difficulty, but the proposed algorithm solved easily. So to illustrate the steps in proposed algorithm, figure 1 illustrates first step. So here, figure 1, an initial Sudoku configuration is empty. So dapat sa atuang, 'di ba, ang Sudoku mostly naa siya commonly naa jud siya givens, right? Kung hilig mo Sudoku, Sudoku games, givens na jud na siya givens dun. Ang imong buhaton is imo i-fill out ang mga katong empty cells. But diri, since maggamit man ta atong gamiton man ang proposed algorithm, then ato ang Sudoku grid problem is empty. Wala jud siya isulod. Kita may maghimo or magkita may magkuan og numbers. So as you can see in figure 2, so illustrates first, second, and third region. So if we're going back to the steps here from step 1 to step 4, since third region man to siya, so ato ang step 1, initialize the Sudoku grid is empty. So okay na ta diha. Then sa step 2, generates the first subgrid or first region in Sudoku by magic square of odd order 3. And then step 3 generates the second subgrid or second region in Sudoku grid by rotating the matrix or subgrid in step 2. So the third, second, and first rows are first, third, and second rows respectively. And then step 4 generates a third subgrid or third region in Sudoku grid by rotating the matrix or subgrid in step 3. Third, second, and first rows are first, third, and second rows respectively. Now, balita diri. I-zoom in na to para maklaro. So, si first region nato is gikan na siya sa katong akong example nga magic square of order 3. So, si 2, 7, 6, 9, 5, 1, 4, 3, 8. Diba, ako na ni siyang gikuan ay iyahang magic sum is equal to 15. Right? So, kung atong gamiton tong proposed algorithm nga steps, ang mahitabo niya is diri sa second region, magbase ta ani gikan sa first region. Ato ra siyang i-rotate ang matrix. So, ang mahitabo, ang third, second, and first rows diri sa atong first region, mahimo na siyang first, third, and second rows sa ato ang second region. Okay, kung ato jud siyang binagsaon jud nato, di ba, ato ang third nga row diri sa first region is kuan man 4, 3, 8. Kung ato na siyang ibalhin diri sa second region, naa na siya sa first nga row. So, gikan sa third row, na siya sa first. Then, kaning second row nga naa sa first region nga 9, which is 9, 5, which are 9, 5, 1, ato na siyang ibutang sa third row sa atong second region. Diba? Ang atong 951 naa na siya sa third. Diba? 951 pod. Okay. Now, ato ang first nga row sa atong first region nga 276 naa na siya sa second rows sa ato ang second region 276. Okay. And then sa ato ang step 4, which is the third region sa atong figure 2, di ba, third region, same ra gihapon siya og i-rotate ra gihapon nimo ang matrix. So kung usay gibuhat nato sa second region, gabase ta sa first region, mupudot mo buhaton sa third region, then magbase na puta sa second region. So, Inana siya sa atong figure 2. So, sa atong figure 3, ang difference nila is, di ba sa figure 2, nag-focus man ta siyang rows. Atong gi-rotate gikan sa rows. And then diri sa figure 3, ang atong i-swap or shift, i-shifting nato to the right ang matrix, ang mga columns na pod. Okay, so ato ang step 5, generate the fourth subregion or fourth region in Sudoku Grid by shifting to the right matrix or subgrid in step 2. So magbase ta sa step 2. So unsa man atong step 2? Diba atong step 2 is kani ngayon 2, 7, 6. Ang step 2 nato is ang first region, right? So diha ta magbase sa ato ang fourth region. Okay, so ang first, second, and third columns, kung gikan sa ato siyang i-shift, mahimo na siyang second, third, and first columns respectively. So, di ba, atong first diri is, unsa man, 294. Di ba, atong first first column is 294. So, ato na siyang ikuan diri sa fourth nga region, mahimo na siya sa second, ang 294. Di ba, nakita ninyo na naa na siya sa second nato na column. And then, atong second, nga gikan sa first region, second column nato is 753. Kung ikbalhin nato na siya sa fourth region, naa na siya sa third. Atong 753, naanda diri 753. And then, ang atong third column from first region, naa na siya sa first column sa fourth region. Ang, sa may naa, 618. So, naa na siya diri 618. So, inanao na siya. Diba, easy ra kaayo siya kay ang atong gikuan is gi-shift ra nato, gi-rotate ra nato, same number, pero dapat follow jud ta kung unsa nga atong columns ba, rows ba. Okay, now let's proceed to the fifth region. So, fifth region is in step 6. So, generate the fifth subgrid or fifth region in Sudoku Grid by shifting to write the matrix or subgrid in step 3. So, magbase na po ta sa step 3. O sa may step 3 nato, si second region. So, atong fifth region is gikan na siya sa second region. Then, same ang process, shift gyapon nato ang first, second, and third columns or second, third, and first columns. Then, hantod siya sa sixth region. Then, atong sixth region, of course, mag-base siya sa step 3. Okay. Now, let's proceed to figure 4. So, figure 4 illustrates 7th, 8th, and 9th region. So, since 7th region is na siya sa step 8, generate the 7th subgrid or 7th region in Sudoku Grid by shifting to the left. Diba ang ato ang step ato ang step 5 to step 7, which is ang 4th region to 6th region, is to the right man siya, no? Shifting to the right. And then, diri sa ato ang step 6 from step 6 to step 10, which is ato ang 7th region to nth region, is shifting to the left of the matrix. Excuse me. So, ato ang 7th region, mag-base na pud siya sa atong step 2. And then, columns gyapon siya. Dili siya rows. Columns gyapon siya. Same gyapon siya sa atong figure 3 nga columns. And then, ang nakalahi is ang third, second, and first columns nga naa sa step 2, which is ang ato ang first region. So, ang third, second, and first column nga naa sa first region, kung ibali na to siya sa seventh region, mahimo na siyang mahimo na siyang second, first, and third column. Okay, now sa step 9, generate the 8th subgrid or 8th region in Sudoku grid by shifting to the left the matrix or subgrid in step 3. So ato ang ika-8 nga region mag-base ta sa step 3, which is ang second region, and then same columns gihapon siya but third, second, and first column. So atong third, second, and first column from second region, ato na siyang i-transfer sa 8th region, mahimo na siyang second, first, and third columns respectively. And then the last step is generate the nth subgrid or nth region in Sudoku grid by shifting to the left the matrix or subgrid in step 4. So atong step 4 is ang third region. So ang third region nato nga third, second, and first column, ato siyang i-transfer sa atong nth region, mahimo na siyang second, first, and third columns respectively. So completed. Na. So here in figure 5, Sudoku grid solution. So ato na ni siyang, di ba, ato nang gi-combine si figure 2, figure 3, and figure 4. Muna ni siya ang labas niya, ang iyang outcomes, ang results niya. Kung ato ni siyang i-kuan sa magic square, so atong 276 is equal to 50 and magic square is equal to 15, 6, 1, 8. Kung every or each column, each row, each 3x3 subgrids, exactly kuan jud siya equal ang iyahang results. Basin pa og kaning sa ato ang each row sa kaning atong i-plus ni si 2, 7, 6, 4, 3, 8, 9, 5, 1. I-add na to na siya. Equals na siya og 45 each row. Kung each column si 2, 9, 4, 6, 1, 8, 7, 5, 3, exactly 45. In diagonal, si 2, 5, 8, 8, 2, 5, 5, 8, 2, 45 dyan na siya. So, nakuha na nato ang solution. So, for conclusion, Sudoku problem can be solved efficiently by proposed algorithm and thus minimize the search space. And the proposed algorithm is the best technique to solve Sudoku problem because an interesting to find feasible solution satisfying the constraints of the problem. So magic square facilities to create the solve. So all references about the Sudoku problem, notice some static numbers given in the possible that are given according to the difficulty rating in the initial Sudoku configuration. The number and location of these determine the game's level of difficulty, but in this research, the proposed method supposes empty all positions in Sudoku grid. And now for the recommendations. Based on the conclusions drawn from the findings, the following recommendations are cited. So students may employ other algorithm in solving Sudoku grid problems such as stochastic or random-based algorithm. So an example of this method is to randomly assign numbers to the blank cells in the grid and then calculate the number of errors. Number 2, researchers may explore more on the proposed algorithm of solving the Sudoku problem. And here is my references of my research study. Okay, so I think that's all for my presentation about my mathematical investigation entitled Math Behind Sudoku using the magic square of order 3 and solving Sudoku grid problem. Thank you for listening and God bless.